Hit go live.
And we're going live.
Hello, everyone. Welcome to KubeCon North America technical demos. We're doing a few of them this week. Kareem did one yesterday for Terraform. That was pretty cool. We're actually using the foundations of that code for today's demo, so I'm pretty excited about that. Let's hope it works. Everybody, please hope that the demo entities are kind to us today, as they were kind to us yesterday. I'm not sure if they were, Kareem.
Mostly. We'll go with mostly.
As you do interact with us, you're welcome to post in chat. You're welcome to ask questions. All we ask is that you adhere to community guidelines, be professional, be welcoming, and be inclusive. With that in mind, we'd love to hear any questions that you have. As I go along, I'm going to be demoing a couple of things. There's a lot of code involved. If there's anything you cannot see, you'd like me to go over a little bit more, feel free to drop a note in the chat. I'll try to monitor it as best I can. And Kareem will try to let me know if there's anything in particular I should go back and refocus on. So today, we're going to talk about my recipe for running Consul on Kubernetes, but we're not actually going to be talking about running Consul on Kubernetes. You can do that with a Helm chart. What we're talking about today is how you're going to use Consul on Kubernetes. A lot of the information you'll find in this deep dive is going to be on the Consul K8's repository in GitHub. That has the Helm chart as well as the container by which you would run Consul on Kubernetes. There's also a Learn collection about how you can get started on Consul Service Mesh with Kubernetes. And there's a whole section on the Consul IO page that is dedicated pretty much to Kubernetes. So you can check out all of those resources here. Today, we are going to be running a .NET and Spring Boot application in containers on Kubernetes. We're all laughing because why would Rosemary want to do this? Well, a lot of applications are not necessarily Go. They're not going to be, not all of them will be the most updated frameworks and languages. And you're always going to have .NET and Java. I love them, so I'm going to run them in containers on Kubernetes, and that's what I'm going to show today. Okay. Oh, speaking of technical demos, if you would like to learn more about the cluster configuration we're using today for Kubernetes, Kareem has a great repository that you can use to deploy any Kubernetes cluster across multiple clouds. What is the non-exhaustive list? I feel like I will miss one. Today we're using DigitalOcean.
We're using DigitalOcean today, but we've also got AKS on Azure, GKE, Google Cloud, and EKS on Amazon. So pretty much everything you want except Raspberry Pi clusters.
Yes, which I guess we could try that. We're not doing that today. But we're going to be doing this on DigitalOcean. The underlying cluster orchestration and platform isn't going to be as big of a concern today, since we're mostly looking at this from an application development view. So if you would like to go through the application I'm showing today, I have a repository available to you. There are a couple things in this particular expense report application. There's two services, expense and report. Expense has a database, so it can access some information. As you can tell, it is about aggregating expense reports. Very, very flashy kind of application, but it does the job. Today, we're going to go through this application and go through a few stories and scenarios and talk about how you can use Consul Service Mesh on Kubernetes in particular and configure it in a way that helps your development workflow. Okay, so the first section we're going to go into is tracing and metrics. I get this question quite a bit, and I did want to sort out a few of the misconceptions about tracing and metrics. First of all, tracing is really difficult to implement in an application. It's known to be pretty tricky. You don't always get the right traces. Trying to get the right information is non-trivial as well. And metrics in Kubernetes is made easier, especially by CNCF tooling like Prometheus. So you can get the information that you need, but what does it mean in a service mesh? So when your platform team or your Kubernetes team tells you, hey, we've got a service mesh on Kubernetes, what does that mean for you when you're trying to implement tracing and metrics? So in our application today, we've got the expense application. It is backed by a Microsoft SQL Server database. Yes, we're running a database on Kubernetes for the sake of example today. I'm sorry, everybody. And then there's a report application that's going to connect to the expenses. So the expenses creates and grabs the information about the expenses. The report application aggregates it as if it was an expense report. Today, we're focusing on, well, getting traces and metrics out of these applications. We need to instrument these particular services to send information to Jaeger and Prometheus. If you're not as familiar with Jaeger or Prometheus, that's okay. If you're using your own tracing and metrics tooling, that's fine. Today, we're going to be using Zipkin spans, and we're sending those HTTP spans to a Jaeger collector. And Prometheus will be collecting metrics from all Envoy proxy sidecars. So if you're not as familiar with service mesh, basically there's a proxy sidecar that runs as part of every application. That sidecar container sends and gets information from Consul. Consul is the control plane or the main plane that is commanding and managing all of the configurations for all of these proxies. And so tracing and metrics isn't something you get out of the box. And that's a little bit of a misnomer, right? Metrics you sort of get out of the box because Envoy is exposing its own metrics, which I'll show. But spans are not something you get out of the box. Traces are not something you get out of the box. The proxy sidecars will grab the information, but you have to have instrumentation in your application to propagate the traces. So you don't just turn on your service mesh and get the traces. That doesn't happen. You actually have to have some code libraries in your application to collect those traces and pass them on to the next service. So that's something to understand. So what does this look like in Kubernetes? Okay. So we've got a couple configs in here that are, I guess, a little complex, and I'll go through some of the more important ones regarding tracing first. So remember, I mentioned that tracing does come as part of a mesh. You do have to configure the proxy sidecar, specifically the Envoy proxies, to do tracing. In the case of Consul, you need to add something to proxy defaults. We have custom resource definitions for a number of Consul configuration entries now. So as a development team, if you're going into this service mesh, you can say, hey, I need some proxy defaults. These are things that every Envoy proxy needs to have. So for example, I configure something like a protocol HTTP. I'll also configure a Prometheus bind address. By default now, the Consul on Kubernetes deployment will bind the Prometheus metrics on port 20,200. So keep that in mind. As part of tracing, you need to pass a JSON configuration for the specific Envoy tracer you want to configure. In this case, I'm configuring a Zipkin Envoy tracer. As part of the current Envoy version that I have, 1.18, you do have to configure with version 3. So keep that in mind. I'm going to configure a collector that is for Jaeger, and it will collect Zipkin spans. So that's where this API endpoint is. It is collecting version 2 Zipkin spans. However, some of my application libraries that I'm using do not use version 2 of Zipkin spans. They use version 1. And so it will accommodate for that, but keep in mind that if you have, let's say, an older application that you aren't able to reinstall or update new libraries for it, you might end up having different kinds of versions for the tracing spans. So keep that in mind. The other thing that you'll also need to configure is an extra static cluster. This is a static cluster definition for Jaeger. So in this case, I'm going to configure this cluster in Envoy called Jaeger_9411. And it will go to this socket address, which resolves to internally in Kubernetes, Jaeger.default.service cluster local. So this is the Jaeger service. It's the collector that is on port 9411. Any questions so far about tracing configuration for the proxy?
Nothing in the chat, but I had one that I'm curious about. You're using the HTTP protocol, and one of the back channel questions that we got, feel free if you're watching this on one of the Slacks to also hop in the YouTube chat and ask the questions there. But the question was, why are you using HTTP and not HTTPS?
Yeah, so you can configure it. For the sake of this demonstration, though, I am sending the span to Jaeger over HTTP. You can configure it as such if you would like to for extra security. But really, if you're not using something like Zipkin, and that's where the tracing space in particular has undergone a lot of changes and improvements, right? You should in some ways be updating your application libraries to be using something like OpenTelemetry, a newer kind of tracing and instrumentation protocol that is not HTTP. So you could do something like gRPC. There are a lot of different configurations you can set up. I'm using Zipkin spans in particular because my .NET Core application, yes, it is .NET Core 2.2. .NET is on 6 right now. So this is not an application that's been updated, and 2.2 is actually end of line. Like I can't even run this locally on my machine anymore without updating it to .NET 6. And so because .NET Core, the library at the time when I wrote this application, did not have OpenTelemetry, or OpenTelemetry for C# was in alpha, I was using Zipkin for .NET, which is a little bit more advanced in that it was integrating with Zipkin, and they, for the most part, they communicate with HTTP spans. So the result is that there is a sort of a legacy backwards compatibility situation, which is why I'm not showing the ideal tracing scenario. But that's the reality of application development. You're not going to get applications that are 100% updated all the time. And in some ways, my hope for this exercise was to show you don't have to add too much instrumentation to an existing application to get tracing to work. You do have to do certain configurations and keep those compatibilities in mind. All right. Any other questions?
Nothing in the chat, but I can see how it's generally a problem that, you know, we're always dreaming of this beautiful greenfield setup where you can just pick all the best technologies right now. I mean, we're at a conference, right?
Yeah.
You're going to have conference-driven development. You're going to be excited about all the stuff that's coming out and you know, deploy a completely new stack tomorrow. But the reality is, it is not the reality.
No, it is not. And just to show you that this is an application in terms of .NET in particular, I have a blog out that if you are trying to add instrumentation to your .NET application, you can reference for kind of the nuances. But for example, in the case of .NET, I have to inject the Zipkin library. So let me see if I can pull up the startup program or startup. There we go. I have to inject the tracer interface into there. I don't have custom spans defined. I don't have anything special defined. One thing to keep in mind is that tracing Envoy really only works over HTTP. So if you have a TCP service, a TCP defined service like my database, so for example, Microsoft SQL Server does not run over HTTP. It's a TCP protocol that's its own protocol. It does not pick up traces. It doesn't propagate trace headers, right? So the only way I would know how it's connecting to the database is through custom spans that I add in my application. So in some situations, you won't get those like all of the spans end to end. You have to be really conscientious about where you're putting some of this information. So for HTTP in particular, I'm able to add a tracer interface into the application, and I don't need to add anything custom to it. So you'll notice there's nothing in the controller, for example, that's particularly custom. It's mostly just picking up this tracer configuration, and it will send it to Jaeger as Zipkin spans. However, it is a lot easier, I would say, in Spring Boot. Spring Boot has a little bit of a difference in that you can load it as part of your dependencies. So you'll notice I'm using Sleuth here. And so I've loaded it here. And once you've loaded it as part of your build and your compilation, it injects it automatically. The one thing that I will say is that if you want database tracing, for example, if I wanted to know the traces going to MySQL, I do have to add an additional configuration. In this case, I'm using Zipkin Brave instrumentation for MySQL, so it's able to pick up those traces as well. So you do have to add other instrumentation into your application. It's not like you can just start up the application without any of this and magically you get traces. I made that mistake. Those spans just don't go to your tracing server. So that is a quick note on tracing. As for the actual trace, I'll actually show one of them. So I'll make a request to the report application. So when I make a request to the report application, it's making an API call. And let's say I'm getting a nice trip ID. My trip ID is D7F. I'm trying to look for all the expenses associated with the trip D7F. So currently I have no expenses, but I should be able to see in Jaeger those traces. So if I refresh and I find traces, it's going through an ingress right now, but you'll notice that there's a huge number of spans here. Some of the things that you'll see as part of the trace itself will be something like a tag component proxy. That tag component proxy indicates that it is going through Envoy proxy. There's some nice information here, right? Get where it's going, what it's going to. As a note, I am using Consul transparent proxy on Kubernetes. There's two methods in which you can run it, and actually traces will work for both. So you can use it with transparent proxy and with direct upstreams. So there's something to keep in mind. So this is more information about expense and all the proxies and all the information, but I'm getting all that in traces, but the only way I'm able to pass this information is through additional instrumentation that I've injected, at least at startup for my application. Okay, so what about metrics? So metrics do come kind of out of the box. Envoy metrics will show up. If you do want Envoy metrics, the main thing that you'll want to add in your Kubernetes configuration for your proxy default in Consul, whoopsie daisies, we'll just, there we go, is this Prometheus bind address. You do have to tell Prometheus where to scrape it from, especially if you have Consul transparent proxy enabled. Transparent proxy provides additional security and that it is locking down the IP tables rules so that only allowed traffic can go to certain ports in certain parts of the container. In this situation, you do want to tell transparent proxy, for example, that it needs to expose 20,200 to be able to scrape Prometheus metrics. So when you scrape those Prometheus metrics, you can aggregate them. The standard ones would be like Envoy cluster upstream requests. There's a number of Envoy metrics that you can pick up and you can aggregate using Prometheus. So that's what I'm doing in this dashboard. We'll come back to the dashboard, don't worry. The other thing that I will note in the case of metrics is that if you're using something like Consul transparent proxy, you do need to do metrics merging, because let's think about it this way. You have metrics coming from your application, right? But you also want to combine them with the Envoy metrics. You don't want to lose the application metrics that you've either instrumented, added, or otherwise. So a good example of this is that I'm using a Kong API gateway. And in my Kong API gateway, I expect to have metrics coming from Kong, for example. So Kong has its own unique metrics. I have to be able to tell Kong itself that, well, I need to metrics merge. So I merge the Envoy Prometheus metrics with Kong's Prometheus metrics. And the way you would do this is adding annotations. So in the case of any application that you have, doesn't really matter. What you do is you add an annotation to your pod that says enable metrics merging, true. This allows the application to accommodate for a different Consul sidecar that will run and merge the metrics for you and expose that. So I tell Consul the service metrics port. So for Kong, it's on 8100, which is the admin port. So I'm telling it to retrieve the service metrics from that port. And those are really the main two. As long as you define that you need metrics merging and which port the application metrics are on, Consul is able to retrieve all of those metrics, merge them together into one endpoint at 20,200 and pass them on to Prometheus. Okay, so with that in mind, those are the main configurations you'll need for tracing and metrics. There's a lot more to this. I won't go too deeply into it, but because we have a lot more to cover. But if you have any questions, you're always welcome to reach out to me on this. There's a few resources I've added. You can check out the blog I mentioned about tracing .NET applications in particular. Spring, as I mentioned, a little bit easier. You can also learn a little bit more about transparent proxy, which does affect how your application exposes those metrics and traces. So if you are an application developer who's working on Kubernetes and you're responsible for knowing how those metrics get sent out, transparent proxy, if you're using Consul, will affect where those metrics are going. So make sure you add the right annotations. On top of that, there's also more information about metrics merging, because it did trip me up when I was doing it. So keep in mind that anything that you're adding as part of application metrics, you will need to enable metrics merging so they combine with the Envoy Prometheus ones. Okay. All right.
Before we dive deeper into this, do you have some guidelines on the things that we should be choosing as metrics to monitor? I know it's always hard, but let's take the example of the expense app. What are some of the things that you think we should also be monitoring?
So some of the things that I would try to divide and conquer, right? Because some of the things that I get out of the box from Envoy, this could be timing, right? So if I have a histogram of what requests are coming in, which requests, what errors, those are actually really something I already get out of Envoy. So those, I actually kind of like that because it's out of the box, which means if I'm rethinking my application metrics, I might not need that. I might not need to be measuring latency anymore. So a lot of the Spring libraries you could inject and it would tell you by default, here's the latency, here's all the information you get. So latency is a big one, but I don't think I would need it in my application anymore, just because I can get that information for the pretty reasonably through traces or through general metrics from Envoy. The one thing I will say that I would remove from I would not just rely on Envoy to do this, is any transactional transactional measurements that you need to do within your application. So in the case of my expense application, I don't rely too much on the proxy metrics delivered for the database calls, for example. That information is pretty difficult to retrieve. There are some metrics that you can do. For example, here, TCP metrics are available to me, but personally, I would prefer to have a little bit more in that, because let's say creating expenses takes a little bit of time. I would want to know why it's taking time or what time it's taking. If it's something like the ingress, right, for an API gateway, I would sort of want to know source as well as who and what endpoints are being accessed. While I can get this information somewhat in Envoy, it's not tracking the exact endpoints that I'm calling. And so if I wanted to know what is a GET request versus a POST request, those kinds of metrics I would want instrumented in my application as well. So a lot of these things, I think some of the timing, for example, might go away if you have a service mesh metric available. But a lot of the application specific instrumentation, like what is happening transactionally, still needs to go in the application. I would keep it there.
I think this is helpful. It does. It definitely does. It always comes down to an "it depends" answer, but it's good to know that when you take a step back, that you can see, hey, maybe I can actually get 90% or 95% of what I need this way without having to change too much about my application. I like that approach. Please continue on.
Yeah, it's definitely interesting. I wanted to start with tracing and metrics because it is very unique. It does change a few things. It's also traditionally very difficult to do. So, you can do it, and Service Mesh will give you a lot of great insight and information. Just be conscientious. There are still some things you have to configure, and you do have to configure it very well in order for it to be effective. So the next thing we're going to talk about is traffic management. And I think this is my favorite, coming from networking. But when we talk about traffic management in Service Mesh is traffic shaping on a very granular level, right? So it's not just as let me load balance 50% here and 50% here. A lot of this you can do in a Service Mesh, and I'll show you some scenarios by which this would be really useful. So let's think about this scenario. Imagine this. My current expense version 1, is using .NET Core 2.2. It's also writing to a database in Microsoft SQL Server. However, it occurred to me that I could do something like vault encryption as a service, some really interesting features. And I talked to my team and we decide, you know what, we'll re-platform the expense application to a different version on Spring Boot. This changes a few things. We can't really write to Microsoft SQL Server anymore. We probably want to be writing to Postgres, MySQL, you choose your database. In this case, I'm using MySQL. Hint, we're going to be talking about Vault encryption as a service tomorrow. So that's why it's been rewritten in Spring Boot. And so in this situation, we've replatformed, but we're not really sure whether or not the application works in Spring Boot, right? We've done the right API implementations, we think, but we're not 100% sure. So how do we control traffic between version 1 of Expense and version 2 of Expense? Can we canary deploy the new Spring Boot application using traffic shaping instead of like the rolling pod, right? So in Kubernetes, you can do a canary deploy with the rolling pods. But in this case, maybe we want a little bit more granular control. We know that we've tested Expense version 2, it's up and running, but we want to be really specific about how much traffic we send to it. Well, the answer is yes, you can do it. You can do it, but you have to use a Consul service splitter. So I'll go through how you use a Consul service splitter for that. So I'll go back to my configuration again. Like I mentioned before, Consul has a bunch of configuration entries. We have them available as custom resource definitions, including service splitter. A service splitter allows you to divide traffic between two services, and you can do that between two services or two subsets of services. So I could even say like there's an expense subset version 1, expense subset version 2, and it would still be able to do this service split for me. Instead, I'm actually dividing between expense service and expense version 2 service. So that way it just makes it easier for me to identify which one's which. So right now I've got 100% by default to expense service, right? By default, if you specify this configuration, it will go default to expense. But let me just shift it to 50-50. What do you think, 50-50, Cream?
Seems dangerous. Let's go 75-25.
75-25. Okay, all right. So we'll send 75% of traffic to the first version, which is in .NET, and then we'll send 25% to the Spring Boot one. And I'll apply it just like a CRD would. So you'll notice that it's a service splitter.consul.hashicorp.com, and it's been configured. What I will see in my application, if I'm not familiar with Kubernetes and maybe you've got a platform team, they'll actually be able to see what kind of routing you have. So for example, 75% is going to expense and 25% is going to expense V2. So you'll be able to tell which one's which. Just to show that it is actually going to it, I'm going to get the expense version. I have a nifty backdoor of sorts where it will output the version of expense. Now 1.0 indicates it's .NET because .NET does semantic versioning, or you can opt to do semantic versioning in .NET. But you'll notice that there's actually a different response the second time I ran the request. And so this is actually going to load balance to the Java version, Java, Spring. You know, most of these builds have snapshots, for example. So here I'm able to issue a bunch of these requests and identify, you know, which ones are coming back, right? It looks like it's about 50-50, which is kind of funny to me. It could just be doing some splits for some reason or another, but here we are. So I can take this opportunity to gradually increase the traffic as I need to and change that. So anytime, if you're doing something like Spinnaker, which is actually really fun, if you do this in something like Spinnaker, you can actually define a CRD with this splitter and control traffic that way as well and do a canary deployment. So you can continue to do this. That's the nice way to configure traffic shaping. So we'll maybe set it at 50-50 and then we'll see what happens. Okay, so the next thing we're going to take a look at is that in our new Spring Boot application, we're not really sure what we've done configuring the database. There's always a period of time where we're trying to understand the database behavior, what we're doing with it, how we're interfacing with it, and we might need to make some optimizations. But we've noticed that the MySQL database is not very reliable. It goes down. We're not really sure what's happening here. And the problem is that when the database goes down, our Spring Boot application takes forever to return an error. It takes, you know, let's say 20 seconds, right? To say, hey, there's something wrong, I'm returning an error. The problem is now report is being held up, right? Because it can't get to any of the information it needs. When you have lots of services tiered together, it's going to be catastrophic, right? You get a cascading failure that if one is sitting there for 20 seconds, waiting and retrying. Then the next one's sitting there exponentially trying to retry and figure out what's going on. And the next one. So we want to fail fast. In this case, we can configure something like circuit breaking. Spring has libraries for circuit breaking, like Hystrix. However, some of them are being deprecated. So you can do a similar behavior in a service mesh, and that way you don't have to inject the library, right? That's the really the best part about this. You don't have to inject the library. You can instead use Envoy outlier detection, which implements a form of circuit breaking. So don't be confused. There is Envoy circuit breaking and there's Envoy outlier detection. We are using outlier detection today and not circuit breaking, right? But outlier detection provides a form of sort of the theoretical implementation of circuit breaking in this scenario. So let's actually start this because it's going to take a while to run. So,
I also have some expenses I need to get in. So if you could get this started, that'd be good.
Yeah, I will definitely get this started. So I am deleting the database. This is my way of saying the database has a problem. Could I inject? Yeah, I know. Kareem off screen is like horror. View the look of horror on his face. But I'm deleting the database mostly because it's a good way to mimic this. It's not realistic necessarily, but it's very hard to inject latency or anything else into a MySQL database at this point. So we're just going to do this. And I'm running Locust specifically. Locust is a load, kind of like a load application, a load generating application. You can use K3s. There's a lot of other options. Let me make sure this is right. I'm using Locust just for ease of use and also because I want to be able to see the real-time metrics with K3s, for example. K6s. What is this? What is the load balancing? There are too many Ks. K6 load test. Is it called K6? Yeah, it's called K6. Apologies. Sorry, everybody. It's called K6. With K6, you don't get streaming metrics, so I did want to show this live, but you'll notice that a number of them have failed. There are a lot of failures, and they'll keep failing. So when you examine the application here, you'll notice there's a number of them that report successful requests. This is because, remember, we've split between .NET expense and Java expense. So some of the requests are going through, 50% are because we didn't take down the .NET database, just to prove. The .NET database is still up. So my Microsoft SQL Server still up. MySQL, not so good right now. And what you'll notice is there's actually the ejection that's happening. So when you do outlier detection in Envoy will eject the cluster from use, right? So we'll say, okay, this cluster not working. We're just going to throw 500 errors really fast, right? And that way you're not sitting there waiting and churning and trying to figure out what's going on. So expense V2, which is this one here, did have an ejection. So then you'll notice that it had the ejection. Subsequently, you'll notice that the other ones, the upstream applications, including report, also had ejections too. So keep that in mind. There are some things here. The graph is a little messy because I think we started a little interesting, but it's detecting a bunch of these 500 errors. And so now it's going to return that information and eject it from the pool. But you'll notice that a number of them are still reporting, coming in and saying that the request has been successful. So
I just have a ton of receipts that I need to get in there.
Yeah, high frequency expense reporting. And if you want to even go a little bit further, you want to check out what's going on, you can even use your handy dandy tracing. And your tracing will even show you that there's a problem, right? So it got to the expense proxy, for example, there's a get, but there's an error. So you'll even get that information as part of your traces as well. So you'll even get some nice information about the fact that it can't acquire a JDBC connection. That means the database went down. So it's cool. It's good information. I'll stop this right now because then I think we might bork the rest of this. We're going to recover it, which basically means me bringing up the database again. So that's kind of the short discussion of outlier detection. If you do want to configure outlier detection, I actually omitted the configuration. It is actually a CRD as well. So you need to configure it as part of the upstream. In this case, let's say I have the service default of the upstream, which is report. So report communicates to expense. Report is the upstream of expense. You need to configure the outlier detection as part of the upstream service. So report has an override, an upstream config override. No, sorry, of the downstream service. You need to configure it in the downstream service, which is report, of the upstream, which is expense. So in this case, report connects to expense. My upstream config has an override, and it has a passive health check with an interval of 10 seconds. And the maximum number of failures that it will record is 3 before it then ejects it, right, from as an outlier from the clusters. So if you do configure this, you will need to examine the downstream application. That's the service that's calling the one that you want to circuit break. And then you can set this information. And this only works for HTTP. I can't do this on the database, for example. So I won't be able to set this passive health check for the MySQL database. I have to do this as part of report. Okay. Finally, let's go back to here. Let's double check that this is working again. We'll see. Stuff is running again. So we'll see how it goes, but it may or may not come back up. So, oh, there we are. Okay. So it's coming back up. Hopefully it will come back. But in the meantime, we'll just do this. Okay. Let's see. All right. So finally, the next bit of traffic shaping and the last bit of traffic shaping I did want to show is service routing in service mesh. So the difference between the service splitter and service routing is the service splitter splits traffic by a certain weight between two services or two subsets of services. A service router allows you to define paths, headers by which you should route this request. So in this case, let's imagine that I have report version 3. Report version 3 offers a new API field. The new API field calculates the total reimbursable expenses. So some of the expenses are not reimbursable, and I need a way to total that up. So I need some way of debugging this new version of version 3. And in this case, I'll configure a Consul service router for that. So the Consul service router looks a little bit like this. If you examine this Consul router here, I am using something called a subset, a service resolver to define subsets. So if you're doing something like subsets, so you didn't deploy a new service, you just deployed a new deployment maybe, but you want to keep the same service name. So for example, I keep report as a service name. I just have two different deployments. One is version 2, one is version 3. I can define something called a subset, and the subset you can filter on a variety of metadata in Consul. But in this case, I used an annotation to tag version 2 and also tag version 3. So if you examine, let's say this one, we'll check it out. You'll notice there's only one report, but 2 instances. And this is because I have 2 instances, one of which is version 1 and version 2, and one is version 3. So these are 2 different pods, but they're registered under the same service in Consul. And I need a way to divide those subsets. So in this situation, I have defined a subset under version 3 as service metadata version 3. So this is a tag that gets propagated to Consul, and that's how you can identify service subsets. So in the case of a router, I'll define subsets version 2, version 3 with a default version 2. And then I can configure a service router. What my service router will do is check if the route that comes in to the proxy matches a header. So for example, if I put in xdebug equals 1 header, it should route to version 3. So just to show what it looks like, you'll notice that in the default get report, when I make a report request, it has a number of expenses and a total, right? So there's 4 fields: trip ID, expenses, total, number of expenses. Now let me get a debug. Let's say I'm trying to check if this new field works, right? I'm going to issue a debug header. So that's where this xdebug equals 1 header is. And then once I check the field, I have a new field called total reimbursable. So that's one way in which I'm able to debug a new service, right, through service routing. You can specify a lot of different paths, but in this case, I'm using headers. How did I get the header passing through? Well, I have an ingress, an API gateway, and the API gateway is preserving the headers for me. So that's why this is getting passed through. Okay. All right. Finally, since we are coming up, oh, go ahead.
I was going to say, it says total reimbursable is still 0. Is that a bug, or is my stuff just not approved?
Your stuff is not approved. No, we haven't actually created any expenses yet. We're a little locked down. We haven't created any of the expenses yet. I'll show you what happens when we create the expenses. But for now, we have no expenses. Sorry, Kareem. I think all of yours went in, but they just weren't approved, or they all failed. Might have been when the database went down.
That database definitely did go down, and I'm guessing my expenses went away with that. Let's continue on. I'll resubmit them.
We don't have high availability in this environment yet. So if you have more questions on traffic shaping, et cetera, there are documents on the Consul docs about all of these configuration entries, service splitter. Make sure you set service default overrides for outlier detection, service routing. So all of these things are available to you. There's a nice tab too that says HCL or YAML. You can choose YAML and it will show you the Kubernetes custom resource definition. So it's really neat, and you'll be able to define whatever you need to. So this is pretty much the traffic shaping approach. Finally, we're going to get to this one, which is API authorization. Many times your application will require some kind of API authorization, especially if you have a lot of API-based services. That's why you maybe have an API gateway. In which case, API authorization is a little bit tricky. Most of the time, you'll try to implement this either externally, so you might have some kind of authorization server, or you have some kind of internal mechanism to do it. Spring, I keep citing Spring because it has all this instrumentation, but Spring does have, let's say, an API authorization library that you can use. However, when you have lots of different applications, like, I don't know, a .NET application as well, those libraries may or may not exist. The equivalent may not exist. And it's hard to have one layer across all of these heterogeneous languages and frameworks that will offer this kind of capability. So you can do a form of API authorization through service mesh. And I'll show you how you would do that using Consul intentions. So in this case, we've got a lot of API calls. You'll notice that there's API calls from the API gateway into report and to expense. For example, I'm allowing everybody to create expenses, but I'm not allowing people, for example, to just get expenses. I don't want them to get the expenses from the outside world. I only want report to retrieve information from expense. Similarly, I just want people to get their report. I don't want them to go to the other parts of the report API. To throw in a little bit of an interesting wild card in here, Vault is running as part of the mesh. Vault was deployed by Helm chart, and I added annotations to Vault for it to run as part of the mesh. There are some nuances there. If anybody's curious, I'm happy to do that. I go through that a little bit if we have time. But for example, maybe I want to control access to Vault. I don't want all the services to communicate to Vault. I just want, expense being able to get that information. Report should never, ever, ever communicate with Vault, for example, because report has no reason to. So here we are. I need to be able to control API access, and in which case I can use something like Consul intentions to do that. So I'll show you what the Consul intentions look like. Okay. So Kareem, you asked before, where's my reports? It could be that I didn't have an intention set for you to do that. So let me just check whether or not you're allowed to access this. A lot of these are created by CRDs. I'll show you the CRD. They are a service intentions CRD, and you can use that to configure any of the kinds. There's two kinds of intentions. There's I guess what you call layer 4, which is TCP intentions. And then you have more fine-grained API access control that you can specify, and that would be app aware or layer 7 intentions. So here, what I have source report. Oh, this is kind of weird to see. You know what? We're going to go to the CRD. I think that will be easier for everyone to view. The UI is nice. I'll show the UI view because the intentions actually map it for you. But let's say I have this API gateway. The API gateway can access expense version, which is why I can get the expense version, and it can get the trip, right? It can get anything under the path prefix of trip. So that allows me to configure something to report. Expense is a little bit more complicated. Expense allows report to make calls to it. It can get something like trip information, but report proxy, you'll notice it doesn't have a get method. It can only create. So let's actually try this, right? Make K8 get report. So remember, this is me getting the report. If I want to, let's say, I don't know, get the expense, right? Because remember, the ingress can create expenses, but it can't get expenses. So let me try to get an expense. Well, this is interesting. I am not allowed to, right? And that's because I don't have an intention that allows me to access that API. So my API gateway cannot get anything from expense. I've not allowed anybody to do that. And I did not do this in code. I didn't do this in, let's say, some kind of separate API configuration. I've done this in my service mesh, right? Which is using an Envoy filter. All right. So let me actually create the expense because, why not? We can create some expenses. And so the first one is some gas. Sorry, it's tricky to read. We've added some gas and we've added some lunch. It's about lunchtime for me. So, I'm adding these expenses. And what you'll be able to find is that if I've added it correctly, you'll find that both of them have been added. And now I've got a total that's not 0. Kareem, you can add this as well. I don't believe I blocked any access to the ingress, so you can add and log your expense if you want.
I might need to. Let me give this one a try.
Yeah, I might have locked it down though, so I can't be entirely sure. Anyway, what you can tell is that if you click on one of the, in the console user interface, you are able to tell kind of what is the routing and the topology for some of this information. So for example, expense has access to the Microsoft SQL Server database as well as Vault. The intention is set up for expense to communicate to Vault. And that means that it can retrieve database username and password by injection. And that's pretty neat. However, if you check report, which is what we did before, if you check report, it's able to get expense and expense fee too, but you'll notice that Vault is not on this list. You'll also notice that, let's say the database is not on this list, so it's not able to access the database. It's not able to access anything except for expense and its version 2, as well as the ingress that the API gateway is able to access report, for example. So I have a lot of control over traffic between the services within the mesh. I can do this with different kinds of ingress. Whatever kind of ingress you want to use, you can use that control. The one thing that you might not be able to see at least not very clearly is with the intentions, is that if you have something like a TCP service, you cannot configure an application aware intention. So you'll notice, for example, expense to database is a full allow. I can't control, let's say, Microsoft SQL servers access. I can't tell it to go to a certain endpoint because it's a TCP service. I could do that with Vault, but Vault, generally speaking, I kind of left it up to Vault's policies to control that rather than me configuring my service mesh and knowing which APIs it needs to access. It's sufficient for me to say, okay, the expense Microsoft SQL service can access Vault so that it can retrieve a root database password and username. With that, I think that is pretty much the entire demo of API authorization. If you would like to have more information, you want to give it a try yourself, you can check out the service intentions configuration entries. You can configure both app aware as well as the layer 4 intentions. So both can be configured. You can check out all of the Kubernetes custom resource definitions. There are a number of them. We have a tutorial, and you can even check out how you can add an ingress that isn't necessarily Consul to this. So for example, I have Kong API Gateway in here, and I have that added. There are a couple things you do need to include from annotations, things that you need to understand with how it interacts with transparent proxy. So there are some details in there. Other than that, any additional questions?
Yeah, I'm getting access denied, which clearly means that my expense is not getting paid today. This is very sad.
You don't have access, Kareem. Maybe the wrong header. Maybe the wrong auth header.
I'm pretty sure it is. But so I'm curious, what are we going to talk about tomorrow? Do we have a preview?
Yeah, so tomorrow we will have Rob and maybe Nick Jackson talking about Vault on Kubernetes. I showed a little bit about the Vault on Kubernetes doing database secrets injection. I didn't go through it today, but tomorrow they're actually going to show using the encryption as a service, so the transit secrets engine of Vault, to be able to encrypt and decrypt data coming from the database, right? So you'll have a service and you're able to encrypt or decrypt the information. This is some really great patterns and some really interesting possibilities from a compliance view. So if, for example, someone no longer has access to the system, you can change or revoke that encryption key so that they don't have access anymore, right? There's a lot of interesting patterns that you can do with that. And so it's going to be a very intriguing one. I look forward to seeing what they do. I believe they're using this application again, but I can't be 100% sure. I believe they'll be doing it in Spring Boot. And there's a link in the chat as well if you would like to check out part 3 tomorrow. It's the same time. And in the meantime, today, if you have more questions about Consul and Kubernetes, there's a whole list of resources that I'm putting on the screen. One of the things to keep in mind is that CLI for Consul on Kubernetes is an alpha. There is a CLI that wraps around the deployment as well as the configuration of Consul on Kubernetes. It is something that you can try. We did not show it today. The link is there. If you do want to learn a little bit more about Vault and its integration with Consul on Kubernetes, I know that the team is working a little bit on that as well. So anything that you'd like to see in particular about Vault and Consul together, for example, that could be certificates, that could be, tokens. It could be a number of things. I believe the Consul Kubernetes team is going to be looking into it more. So have a chat with them if you're in the KubeCon Slack. On top of that, the Vault discussion we're going to have tomorrow is more about using Vault on Kubernetes and less about the integrations. So if there's anything in the meantime, you can always let us know. But with that, anything else?
Yeah, definitely a shout out for the YouTube, not the YouTube channel. Also check out our YouTube channel for more content like this. But I was gonna say, check out, was it #6-KubeCon-HashiCorp? Just rolls off the tongue on the Cloud Native Computing Slack. Find us there. If you have any questions, most of us are hanging out there the whole day. Let us know what you are missing from today's episode, what you are curious about. Maybe you have your own expense application. We won't be processing your expense reports, but if you have other questions, we're definitely here for you.
Yeah, definitely. And if there's anything that you would like to know a little bit more about in this particular demonstration, you can check out the expense report application link that I had earlier. I'll include it in the description as well. And it will include some information that if you want to know how to add Vault to a service mesh, it has the right annotations in place. There are some nuances there that you do have to know about. Like excluding outbound ports and including outbound ports, excluding inbound ports. And there's also more about how to set up API gateways in particular. So there's a couple of tricky annotations that you'll need, and those are documented, but the combination of them can be particularly difficult to reverse engineer. So do keep that in mind, that there are a couple of annotations that you'll need to add as well for any of these configurations.
And we put links to pretty much everything into the chat. We'll make sure they show up in the show notes. If you're quick enough, you can just take a screenshot if you can't wait for the links, but they'll be there.
Yeah, exactly. All right. Happy KubeCon, everyone. Enjoy. Thank you for joining us on this journey. Thanks to Kareem for putting the amazing Terraform Terraform configuration together so that I could run this on DigitalOcean. And he made one for Google for me because I was running this on Google originally. So he's made a couple of them. And any of the configurations that you've seen here will run on any Kubernetes deployment you choose. It does use load balancers though. It does use load balancers for access. So keep that in mind. And if you try it, check it out. And we'll hopefully have you at the Vault technical demos tomorrow.
Yeah, definitely come back tomorrow. Thank you for joining us today. Yeah, I think with that, let's hop on over to